Hello, Assalamu alaikum. My name is Musa Ali Khan and today I will teach you one rule to find particular integral. Now, there are some rules to find particular integral, but today our topic is case 4 or rule number 4. Whenever in any question when your fx is equal to eax phi x, then your yp should be 1 upon function of d eax phi x is equal to phi x. Then you should apply this rule that 1 upon function of d eax phi x is equal to eax 1 upon f d plus a phi x. We will study it later. Now if we have an example, if we consider an example that कि हमारे पास e2x sin x एज एन fx में आ रहा है, तो हम लोग उसको किस तरह सॉल्व कर सकते हैं? To solve the example, we have few steps. Number 1, we have to find its complementary factor yc. Second step, we have to find its particular integral. Now for yc, d cube y dx cube minus 7d square y upon dx square plus 10 dy upon dx is equal to e2x sin x, which is our main equation. Then first of all we make its auxiliary equation, which is d cube minus 7d square plus 10d is equal to 0. For roots of yc, we just have to replace d for m cube. Now our equation becomes m cube minus 7m square plus 10m is equal to 0. Now by taking m common, we get our one root m is equal to 0, and are continuing our equation m square minus 7m plus 10. We should get our second and third. We also get our second and third roots. First root, second root, and third root. Now therefore our equation would become yc is equal to c1 plus c2 e2x plus c3 e5x. Now for yp, which is also called as particular integral. Now the formula for solving yp is 1 upon function of d e power 2x sin x. Since we know that our function of d is equal to d cube minus 7d square plus 10d, therefore we just have put it in the place of function of d. Now our equation becomes 1 upon d cube minus 7d square plus 10d e2x sin x, e the power 2x sin x. Then we first have to put d is equal to d plus a, d square d plus a square, and d cube is equal to d plus a ka whole cube, and a is of e power eax. Now in this, it is a rule in our, and this is the rule to find yp in this particular equation, that we just have to add the constant of exponent in the denominator, and then we just have to expand our yp. It is our rule that we have to done this. Now as you can see that there are many d square in our all equation. Therefore for the sin x, we just have to put d square, we just have to put minus a square in the place of d square, and a is the power of sin x. Since we are seeing right down here that the power of sin x here is 1, a is equal to 1, therefore we put d square is equal to minus a square is equal to minus 1 square. And after all addition and subtraction, we have find that our yp is equal to e to the power 2x 1 upon d cube minus d square minus 6d sin x. Now by putting d square is equal to minus a square, which is minus 1 the whole square, we just get yp is equal to e to the power 2x 1 upon 1 minus 7d sin x. Now by multiplying and dividing by 1 plus 7d, we just get this equation. Yp is equal to e to the power 2x 1 plus 7d 1 upon 1 minus 49d square sin x. Now since we know that whenever we see d square, we just put minus 1 the whole square. Therefore we just replace d square by minus 1 square. Whenever we see d square, we just put the constant of sin x, which is in power. So after putting that, we just get our equation like this: yp is equal to e to the power 2x 1 plus 7d upon 50 sin x. Now by continuing our equation, we just get, now by differentiating, yp is equal to e to the power 2x 1 plus 7d upon 50 sin x. Now by differentiating, we just get e to the power 2x sin x plus 7 cos x upon 50. Now this is our particular integral. Since we know that our yc is equal to c1 plus c2 e2x plus c3 e5x, therefore we just write our general solution as y is equal to yc plus yp, y is equal to c1, and our answer should be y is equal to c1 plus c2 e power 2x plus c3 e to the power 5x plus e power 2x upon 50 sin s plus 7 cos s. Thank you. I think you just have enjoyed our video. Please subscribe and like our video. Thank you.